All right, today we're going to talk about exponents. Remember, exponents has a base, and then the little number on the side is the exponent. So I can write and evaluate numerical expressions with and without grouping symbols involving whole number exponents. All right, so select all the expressions that are equivalent to 64. So 2 to the 6th power means 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 times 2. So that's going to be 4, 4, 4. That's going to be 16 times 4, which is 64. So A is good. 2 to the 8th power. That's going to be 2 times 2, 4, 5, 6, 7, 8. Well, I know that if 6 2s is 64, 8 2s is definitely not. So I'm going to have 64 times 2 times 2. So 64 times 4 is going to be way too high. So B is out. C is 4 to the 3rd power. So that would be 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. So C is good. 8 squared is going to be 8 times 8, which is 64. 16 times 4 is going to be 16 times 16 times 16 times 16. That's going to be huge. So E is out. 32 times 32, that's again going to be huge, so that one's out. So you should have had A, C, and D. Select all the expressions that are equivalent to 3 to the 4th power. Well, 3 to the 4th power is 3 times 3 times 3 times 3. So that's going to be 9 times 9, which is 81. So I want my numbers to be equal to 81. So I know A's out, I know C's out, I know E's out. So I'm looking at D. So no, no, and no. All right, so now I've got to figure out B and F. So 4 to the 3rd power means 4 times 4 times 4, which would be 16 times 4, which we figured out is 64. So B is out. So then 9 squared is 9 times 9, which is 81, so F is in. Select all the expressions that are equal to 3 times 3 times 3 times 3 times 3. So that would be 9 times 9 times 3, so 81 times 3. So that's going to be 243. That's what I've got to make it equal to. So 3 times 5, that's going to be 15, so that's out. So 3 to the 5th power, that means 3 times 3 times 3. So that's exactly the same as before, so B is in. C is 3 times 3. So that's 3 to the 4th power times an extra 3, so that one's in too. Because that's 5 3s, and I have 5 3s again. 5 times 3 is going to be 15, so D's out. 5 to the 3rd power is 5 times 5 times 5. It's going to be 25 times 5. That's 125. So that's out. So it should just be B and C. All right, explain whether each is true or false. Explain how you know. So I have 9 times 9, which is 81. 81 times 3 is 243. So is 243 equal to 3/5? Well, on the previous slide, 3/5 is 243. So this one is true. The next one, are they equal? Well, 7 plus 7 plus 7 is 21. So then 3, 6, 9, 12, 15, 18, 21. So that's true. So then 1/7 times 1/7 times 1/7. Well, 1 times 1 times 1 is 1, but 7 times 7 is 21. 21 times 7 is 147. That's not equal to 3/7, so that's false. Then 4 to the first power means just 4. Is that equal to 4 times 1, which is 4? So that's true. So A, B, and D are true. This one is 6 plus 6 plus 6, which is 18. Is that equal to 6 times 6 times 6? Well, that's 36 times 6, which is 216. So this one is also false. So C and E are false. A, B, and D are all true. Evaluate each expression. So I have to 7 plus 2 to the third power. So 7 plus 2 times 2 times 2. So order of operations is going to come into play. So I have to multiply before I add. So 2 times 2 is 4. 4 times 2 is 8. So 7 plus 8 is going to be 15. All right, then B is 9 times 3 to the first power. So that's 9 times 3, which is 27. C is 20 minus 2 to the fourth power. So I have to do exponents first. So 20 minus 2 times 2 times 2 times 2. So that's 20 minus 16, which leaves me with 4. D is 2 times 6 to the second power. So that's 2 times 6 times 6. It doesn't matter the order here because they're all multiplication. So 12 times 6 is 72. All right, and then E is going to be 8 times 1/2 to the second power. So that means 8 times 1/2 times 1/2. So I'm doing 8 times 1/4. So I get 8/4 or 2. I'm going to switch colors. F is 1/3 times 3 times 3 times 3. So I know 1/3 times 3 over 1 is going to give me 1 times 3 times 3. 3 times 3 is 9, times 1 is 9. So 9 is my final answer. Then I have 1/5 times 5 over 1. That's in parentheses to the fifth power. So what's in the parentheses is going to go first. So 5 over 5 to the fifth power. So that's going to be 1 to the fifth power. So 1 times itself 5 times is still going to equal 1. So then it says I multiplied 4 by 5. So 4 times 5. Then they cubed the result. So they did this first, then they multiplied it all by 3. So I have to have parentheses around the 4 times 5. So cubed, that means to the third power. So B will work. A does not work because they're cubing the 3, not the 4. B is a yes. This is squaring it, so that would be a no. That's cubing just the 3, or just the 5. So D is a no. 20. So 4 times 5 is 20 to the third power, so that would be a yes. So then 20 to the third power, what is that going to equal? So that's 20 times 20 times 20. So that's 400 times 20. So that'd be 8,000. So F is no. So G is yes. So B, E, and G. All right, decide if the expressions have the same value or not. Determine which expression has the larger value. So 2 to the third power means 2 times 2 times 2, which is 8. 3 to the second power is 3 times 3, which is 9. So which one has larger value? 3 to the second power. 1 to the 31st power. So 1 to the 31st power just means 1 times itself a whole bunch. So that's just 1. 31 to the first power just means 31. So 31 to the first power is greater. So 4 to the second power means 4 times 4, which is 16. 2 to the fourth power means 2 times 2 times 2 times 2. So that's 4 times 4, which is 16. So they're equal. So then 1/2 to the third power would be 1/2 times 1/2 times 1/2, which leaves me with 1/8. And then 1/3 times 1/3, which leaves me with 1/9. Well, in fractions, 1/8 is larger than 1/9. So that one's bigger. All right, here is an expression, 3 times t, 2t. Evaluate the expression when t is 1. So 3 times 2 to the first power. So that would be 3 times 2, because 2 to any number to the first power is just itself. So I get 6. Evaluate it when t is 4. So 3 times 2 to the fourth power. So that'd be 3 times 2, 3, 4. So that's 6 times 2, which is 12. 12 times 2 is 24. 24 times 2 is 48. So now you're going to find the missing exponent or base on IXL and do the cool down.